Hello everyone. In this video we're going to be solving an interesting exponential system. We have x to the power 2y squared minus 1 equals 5 and x to the power y squared plus 1 equals 25. And we're going to be solving for x and y values. I'll be presenting two methods and also show you a graph at the end, which I think is pretty interesting. So let's get started and start with the first method. So for my first method, I'm going to use the fact that 25 is 5 squared. So we can go ahead and write the second equation as x to the power y squared plus 1 equals 5 squared. But from the first equation, 5 is equal to x to the power something. So we can basically replace the 5 with that. Let's go ahead and do it. Replace 5 with x to the power 2y squared minus 1. That replaces 5, and then we have to square it. Okay, great. Now we got an equality, and we can basically put these two together. So now, here's what we're going to do. Since we are squaring an exponential, we're going to multiply the exponent by 2. So we're going to distribute it. And so that's going to equal x to the power y squared plus 1. So this equals x to the power 4y squared minus 2, because we distribute the 2, right? Okay? Awesome. Now the next thing we're going to do is if x is different from 1 or negative 1 or 0, and obviously x cannot be any of those, because you do know from the original equations that if x is 1, then the answer must be 1. If it's negative 1, it can't be 5, unless y is a complex number, so on and so forth. We're not going to get into those complex issues. Let's go ahead and keep it simple. Obviously, we can always talk about, complex solutions if there are any. So this is what we got so far. So in the real world, this would mean that the exponents are equal. So if we set those equal to each other, we're going to get y squared plus 1 equals 4y squared minus 2. Now let's go ahead and put the y's together. Subtract y squared, you get 3y squared. Add 2, you're going to get positive 3. This means 3y squared is equal to 3, which means y squared is equal to 1. You should be able to look at an equation from either side. Doesn't matter, but obviously writing the variables on the left-hand side makes it a little easier. We're used to reading it from left to right, for the most part. Okay, so this gives us two solutions, right? Obviously, there are two numbers whose square equals 1, and those numbers are 1 and negative 1. So we're going to have to look at each case separately, right? So let's look at it case by case. What happens if y is equal to 1? Well, the best way to understand is just to plug it in, right? So remember the original system. It was x to the power 2y squared minus 1 equals 5, and x to the power y squared plus 1 equals 25. Obviously, you do want to check both of them. Let's plug in y equals 1. The first one gives us x to the power 1, which is x, equals 5. The second one gives us x to the power 2 equals 25. And then this gives us two solutions, 5 and negative 5. But the second solution does not agree with the first finding. Notice that we have to satisfy both, so it's an and, right? They both have to be true. So we're going to have to discard the negative 5. So the only solution that we get from here is going to be x equals 5 for y equals 1. Okay? So we got for y equals 1, x equals 5, which means 5 comma 1 is a solution. At the end, we're going to put it all together and also look at the graph, which is going to make obviously a lot of sense. Okay, so far so good. So this is just for y equals 1. What happens if y is equal to negative 1? Here's the thing. It wouldn't matter because you're squaring the y anyways, so y squared is always going to be 1. Therefore, you're going to end up with the exact same solution, x equals 5. And this gives us the ordered pair 5 comma negative 1. So it looks like we got two solutions. Are there any other solutions, at least for the real deal? and there aren't. As far as I know, correct me if I'm wrong, but I don't think there are any other real solutions for this problem. All right, let's go ahead and take a look at the second method, and please let me know what you think about these two methods. Which one do you like better? Which is your favorite? So on and so forth. Okay, usually the second method is my favorite, but you know, it depends. So let's rewrite the original system. X to the power 2y squared minus 1 equals 5, and x to the power y squared plus 1 equals 25. So to be able to solve this system, our first method depended upon writing the 5 squared, or writing 25 as 5 squared. So we were able to set two exponentials with the same base equal to each other, and from there we found the value of y. So we're going to use a different approach. Obviously, it can't be the exact same thing, right? So let's go ahead and do the following. From the first equation, I can not divide. I can first of all write it as follows: x to the power 2y squared divided by x, because when the exponents are subtracted, that indicates division, right? And then I can go ahead and multiply both sides by x, and that's going to give me x to the power 2y squared equals 5x. I mean, this doesn't look very helpful, but at least we were able to get the y squared on one side. And we can do something similar here. Let's go ahead and write this as x to the power y squared times x, because addition of exponents indicates multiplication, and this equals 25. And from here we can divide both sides by 25. I mean x. You know what I mean, right? We get x to the power y squared equals 25 over x. So that gives us another equation. How do we use these two equations? How do you put it together, right? Well, the similar idea. We have x to the y squared and x to the power 2y squared. So x to the power 2y squared is the same as x to the power y squared squared. Why? It's like, okay, it's 2y squared because the exponents are multiplied. Because y squared times 2 is 2y squared. That's the reason, okay? That's why this equality works. Great. But what is that supposed to mean in terms of our system? It means that you can replace x to the power y squared with something, because we know what it is, right? It is equal to 25 over x. So you just gotta square it. Awesome. Yeah, but where do I go from here, right? I mean, this is x to the power 2y squared, but x to the power 2y squared is also equal to 5x. So this is also equal to 5x. Make sense? So this is 5x, and this is 25 over x squared. That's why they're equal, because they are equal to the same thing. Great. Let's go ahead and simplify this a little bit. 25 squared divided by x squared equals 5x. Multiply both sides by x squared, you get 5x cubed equals 25 squared. By the way, 25 squared can be written as 5 squared squared, which is 5 to the 4th power. Awesome. So how do I solve for x? Easy. Just divide both sides by 5, and you should get. So let me rewrite my equation in simpler form like this, and I'm going to divide by 5. And 5 to the 4th power divided by 5 is 5 to the power 3. And x cubed equals 5 cubed indicates x equals 5 as before. But how about the y values? Well, if x is equal to 5, you're going to find two y values by substitution. You already know that, hopefully. Y is 1 or -1. Let's go ahead and take a look at the graph, and then we'll just finish up with that. So here's the graph of these two functions. They intersect at these 2 points, 5, 1 and 5, -1. So those are the only real solutions. And if this graph kind of looks like a hyperbola, but and there's a little interesting piece here. I don't know why we have that, but you could probably prove it. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.